The sun, a celestial inferno, bathes our planet in light and warmth. But beyond the familiar sunlight lies a hidden realm of elusive particles known as neutrinos. These ghostly messengers, born in the heart of the sun, carry secrets of the nuclear reactions that power our star. Neutrinos are subatomic particles with no electric charge and a remarkably small mass. They interact with matter through the weak force and gravity, but their interactions are incredibly feeble. Trillions of these particles pass through our bodies every second, leaving no trace. Despite their elusive nature, neutrinos are essential to our understanding of the universe. Join us as we take you on a journey to unravel the mysteries of these fascinating particles and explore how they are transforming our understanding of the sun. Deep within the sun's core, under unimaginable pressure and heat, a nuclear furnace rages. Here, hydrogen atoms are fused together to form helium, releasing immense energy. This process, known as nuclear fusion, powers the sun and other stars. Neutrinos are born from these fiery nuclear reactions. The primary source of solar neutrinos is the proton-proton, or PP chain reaction. Each cycle of the PP chain releases 2 neutrinos. These particles travel at nearly the speed of light, carrying a whisper of the nuclear inferno from which they originated. In the mid-20th century, scientists realized that neutrinos held the key to unlocking the secrets of the sun's core. However, early attempts to detect these elusive particles led to a perplexing mystery known as the solar neutrino problem. Theoretical models predicted a specific flux of neutrinos reaching Earth, but early experiments detected far fewer neutrinos than expected. The Homestake experiment, led by physicist Raymond Davis Jr., used a massive tank filled with perchloroethylene to capture solar neutrinos. This experiment consistently detected only about 1/3 of the neutrinos predicted by solar models, puzzling scientists for years. The solution to the solar neutrino problem lay in the peculiar nature of neutrinos themselves. These particles can undergo a quantum mechanical phenomenon known as neutrino oscillation. Neutrino oscillation refers to the ability of neutrinos to change their flavor as they travel. There are 3 known flavors of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. The discovery of neutrino oscillation provided strong evidence that neutrinos have a very small but non-zero mass. This mass difference allows them to oscillate. As solar neutrinos travel from the sun to Earth, they can oscillate between these 3 flavors. Early neutrino detectors were primarily sensitive to electron neutrinos, explaining why fewer electron neutrinos were detected than expected. The discovery of neutrino oscillation revolutionized our understanding of particle physics and solved the solar neutrino problem. It also opened up new avenues for studying the sun and other astrophysical objects. Solar neutrinos provide us with a unique tool for probing the sun's interior. Unlike photons, which can take hundreds of thousands of years to escape the sun's core, neutrinos escape almost instantaneously. This means that solar neutrinos provide us with a real-time snapshot of the nuclear reactions happening in the sun's core. By studying the energy spectrum and flux of solar neutrinos, scientists can gain insights into the temperature, pressure, and composition of the sun's core. Neutrino observations have confirmed the stability of nuclear fusion as the sun's primary energy source. Moreover, solar neutrinos can potentially reveal new physics beyond the standard model. For example, some theoretical models predict the existence of sterile neutrinos, which could affect the oscillation patterns of solar neutrinos. As we continue to refine our neutrino detectors, we can look forward to more groundbreaking discoveries that will illuminate the secrets of the sun and the cosmos beyond. The journey of understanding solar neutrinos is far from over. As we develop more advanced neutrino detectors and refine our observational techniques, the potential for new discoveries grows exponentially. Future experiments aim to map the Sun's core with unprecedented precision, revealing intricate details about its dynamic processes. Beyond our Sun, neutrino astronomy is set to explore other stars and cosmic phenomena, offering a new lens through which to view the universe. By unlocking the secrets of neutrinos, we open doors to understanding the most energetic and extreme environments in the cosmos. The study of solar neutrinos not only deepens our knowledge of the Sun, but also paves the way for groundbreaking advancements in particle physics and cosmology. As we continue this scientific adventure, we can expect to uncover more about the universe's fundamental forces and the very fabric of reality. Thank you for joining us on this journey through the invisible world of solar neutrinos. If you enjoyed this video, please like and share it, and don't forget to subscribe to our channel for more fascinating space weather videos. Together, let's continue exploring the mysteries of the universe. Until next time, keep looking up at the stars.